The AP question says, windmills generate electricity by transferring energy from wind to turbine. A study was conducted to examine the relationship between wind velocity in miles per hour and electricity production in amperes for one particular windmill. For the windmill, measurements were taken on 25 randomly selected days, and the computer output for the regression analysis for predicting electricity production based on wind velocity is given below. The regression model assumptions were checked and determined to be reasonable over the interval of wind speeds represented in the data, which were from 10 mile per hour to 40 mile per hour. Use the computer output above to determine the equation of the least squares regression line. Identify all variables in the equation. So again, y equals a plus bx. Here, they give you the variables, constant being the a, 0.137, and wind velocity b, 0.240. So, y equals 0.137 plus 0.240x, which is electricity production equals 0.137 plus 0.240 times wind velocity. The variable constant, defines the y-intercept, and the variable wind velocity defines the slope. How much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 mph than on a day when the wind velocity is 15 mph? Show how you arrived your answer. So for the equation we already have, we will want to plug 15 and 25 into the wind velocity. For the first one, 0.137 plus 0.240 times 15 would give us 3.737, and y hat equals 0.137 plus 0.240 times 25 would give us 6.137. And we want to find the difference, which is 2.4. 2.4 more electricity production in amperes will be produced in one day when the wind velocity is 25 miles per hour than on a day when the wind velocity is 15 miles per hour. C said, what proportion of the variation in electricity production is explained by its linear relationship with wind velocity? This would be the r squared. The proportion of variation in electricity production that is explained by its linear relationship with wind velocity is 0.873.